lesson 12.7. We are doing trigonometric ratios. And what they are is they are sine, cosine, and tangent. What this tells us, okay, is how to find angle sizes or side lengths whenever I'm missing them, okay? So go ahead and write each of these ratios down. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now you will need to have these memorized. Sine is always opposite over hypotenuse. Cosine is always adjacent over hypotenuse. And tangent is always opposite over adjacent. Okay? Go ahead and write them down. You will need to memorize them. Okay, if you can see what I've written up here on the board, SOHCAHTOA. SOHCAHTOA. All right, it's an easy acronym, or I guess would be a correct word, to remember what sine, cosine, and tangent are. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. So it's just an easy way to help you remember. So if you can remember SOHCAHTOA, you can remember exactly what each one is. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. And tangent, opposite over adjacent. So what we've got, okay, is they've given us an example triangle. And they want us to find the cosine, or the sine, cosine, and tangent of angle A. All right? Now, depending on which angle you do, your answers will differ, okay? Because if I look from the view of angle A, the opposite is going to be here, adjacent is right beside, and the hypotenuse is always the hypotenuse. Remember, your hypotenuse means it's which side of the triangle? The longest. So the hypotenuse is never going to change. However, the opposite and adjacent will differ depending on which angle you're looking from. Because if I were to look at the opposite from angle B, it would be right here. But if I look from the opposite of angle A, it's this one. Okay? So they're telling us to find the sine, cosine, and tangent of angle A. So the sine is the opposite. So I look from the view of angle A. And if you want to, just draw a line directly to the opposite. What number do I run into? 8. So I'm going to write 8 for my opposite. Now, which one of these is the hypotenuse? 10, because hypotenuse is always the longest leg. Now, can I simplify 8 over 10 to what? 4 over 5. There's my sine, 4/5. Okay? Now let's look for our cosine. Our cosine is going to be the adjacent side over the hypotenuse. Now, the adjacent is the one that gives people the most trouble because they're like, I don't even know what the word adjacent means. What the word adjacent means is just right next to. So if I'm looking at angle A, it's going to be the side right next to it. But you say, wait a second, there's two sides right next to one. Well, what is this first side right here? The hypotenuse. The hypotenuse will never ever change. So we know adjacent can't be the hypotenuse, so it has to be the other side, which is 6. So I write 6 over my hypotenuse, which is still 10. Simplify that to 3 over 5. So my cosine of angle A is 3 over 5. And last but not least, opposite over adjacent. Now we've already figured out the opposite of angle A. What is it? 8. And we've already figured out the adjacent of angle A, which is 6. So we just simplify. What's 8 over 6? 4/3. Do not change it to a mixed number. You want it to stay an improper fraction. Okay? There's your sine, cosine, and tangent. Just like that. All right, so this is going to be more what your problems on your homework, quizzes, and tests look like. It says find the sine, cosine, and tangent of each angle. It tells you which angles to do, angle D and angle E. Now, these signs right here, you're going to be seeing a lot of them next year when you take geometry. They're just a shorthand version for angle. Instead of having to write out the whole word angle, you just draw a little angle sign. So the first thing we're going to do is look for angle D. Angle D is right here at the bottom. I see the D here. So they want me to find the sine, cosine, and tangent of angle D. So I'm going to write sine, and I write the D beside it so I know exactly which angle it is. Cosine of angle D, and tangent of angle D. All right? So the sine, let's write out our little acronym. So, ha, toa. So what is our sine? What over what?
Sine is opposite over hypotenuse.
Opposite over hypotenuse. So if I'm looking at angle D, which is right here, what is the opposite side of angle D? 5. So it's always going to be the number. So 5, that's our opposite, over hypotenuse. Which one of these sides is the hypotenuse? 13. Can I simplify 5 over 13? Nope. There's my answer. Now let's find the cosine. Cosine is what? What over what? Adjacent over hypotenuse. Remember, CAH. Okay? So adjacent to angle D is what? 12. Remember, it's not 13 because what is 13? The hypotenuse. Okay? So we know that's going to be 12 over our hypotenuse is 13. And last but not least, the tangent. Tangent is what over what? Opposite over adjacent. So what was our opposite? 5. And what's our adjacent? 12. Now, can I simplify any of these fractions? No. So this is my final answer. These are the sine, cosine, and tangents of this triangle. Now, one thing I did forget to mention at the beginning was sine, cosine, and tangent only works with a right triangle. Okay, this is how you find out the measurements of the angles or the side lengths using the right triangle, sine, cosine, and tangent. Okay, so now let's find the sine, cosine, and tangent of angle E. So I'm going to write sine of E. So you just put sine E, cosine E, and tangent E. And obviously you can shorten these. You don't have to write out the entire word sine or cosine or tangent. So let's look from the viewpoint of angle E. Angle E is right here up at the top. So sine is what over what, Janae? Okay, because what's the names for it? Opposite over hypotenuse. So the opposite of angle E, if I were to draw a line, I would run directly into 12. So there's my opposite. And my hypotenuse is still 13. It never changes. Remember that? Okay, it doesn't matter what angle we're looking for. The hypotenuse is always the same. Cosine. Cosine is what over what, Dean? Adjacent over hypotenuse. Very good. So which one of these sides are adjacent to angle E? 5 over, what's my hypotenuse? 13. And last but not least, the tangent. Tangent is what, Tyler?
Opposite over adjacent.
Opposite over adjacent. So what is opposite of angle E? 12. And what is adjacent of angle E? 5. Again, remember, don't change that to a mixed number. Leave it just like that. Any questions at all over how to find sine, cosine, and tangent? Okay? Here's one more triangle that I'm going to do with you guys. So we have got Is our right triangle. Okay, so we're going to find the sine, cosine, and tangent of angle A and angle B. Okay, sine, cosine, and tangent of angle A and angle B. All right, Jason, tell me the numbers that I'm going to plug in for the sine of angle A.
3 and 5.
Okay, sine is what? Let's write our acronym. SOHCAHTOA. So sine is what over what? Opposite over hypotenuse. So let's look from angle A and let's draw a line directly to the opposite. What is opposite of angle A? 4. So we're going to write 4 over the hypotenuse. Which one is always the hypotenuse? The longest one, which is 5. Perfect. Okay, now let's find the cosine of angle A. Betty, what would the cosine be?
The cosine is the adjacent.
Okay. Adjacent over hypotenuse, which is going to plug in to be?
8. Hang on, this hypotenuse is 5.
Okay.
And then adjacent would be 3.
Perfect. 3 over 5. And last but not least, Hunter, what is my tangent of angle A?
4 over.
Perfect. 4 over 3. Remember, don't change that to 1 1/3. All right, here's my sine, cosine, and tangent of angle A. Now let's do the same thing for angle B. Sine of B, cosine of B, and tangent of B. All right, Manuel, tell me my sine of angle B. Who can help him out? What would the sine of angle B be, Megan? 3 over 5. Perfect, because the opposite of angle B is 3, and the hypotenuse is 5. Always has been, always will be. Cosine of angle B is what, Janae? So I just write 4 and 5? 4 over 5. Perfect. And the tangent of angle B is what, Haley? 3 over 4. Perfect. Okay, there's your sine, cosine, and tangent. This is your homework that you are going to do tonight.